Our next speakers are from new participants in the community from Virscidian, so welcome. They will Taylor Janoe, John Adams, and Mark Spears will tell us about their journey creating a allotrope simplified model for LC-MS data.
So we're going to kind of tag team this presentation. I have a few slides, and then I'll tap in John, and then we'll go from there. But before we get started, I just want to introduce you just a little bit to slides advancing. There we go, to who Virscidian is. Some of you may have heard of us before, some may not. So Virscidian is a chromatography and mass spec data platform. We are vendor neutral, so we're taking data from all kinds of sources, from our friends at Thermo and Agilent and Waters and Shimadzu and on down the line. We're providing a common platform for scientists to analyze those data. We're also translating all of that information into a common output. So there's a lot of value in that, in having a data platform that scientists can use to provide consistency for their analysis and also consistency in their reporting. Virscidian is all about automating workflows. So we think a lot about not just individual experiments, but what are the specific workflows that scientists are doing in the lab? What are they trying to learn? And every workflow is different. They have their own needs, their own desires about how they're reporting and calculating. So Virscidian thinks a lot about automating what scientists do in the laboratory. And then we offer, anything from sort of a desktop software all the way up to enterprise solutions where we're automatically sweeping data from instruments. And someone asked a question yesterday, I think it was, they called it the bane of their existence. These chameleons and empowers of the world who put everything into databases. Virscidian has solutions to actually extract files from those kinds of systems and process them and deal with that. So, and then, obviously we're trying to apply the best in class data processing and really get into the details of, how we treat the data, peak picking, integrations, all those kinds of things. We also offer quite a variety of different workflows. I made this slide kind of focused on drug discovery. I think that's probably most people in the room, but certainly we also offer solutions in the material space and the agriculture space, things like that. But we're covering a very wide variety of drug discovery workflows, primarily early drug discovery and not in the regulated environment. And then this is my last slide. I just want to kind of bring this to your attention. So we're very, very excited. Virscidian was actually acquired by Dotmatics. We announced this in September of this year. We're very thrilled about this acquisition and partnership with Dotmatics. We bring a lot of chemistry expertise to their platform, and Virscidian handles primarily small molecule data analysis. We also have protein metrics that's doing a very similar type of analysis for large biomolecules, and all of our solutions and many, many others are feeding into this common platform at Dotmatics. So we're very excited about this partnership and very optimistic about the future together. So at this point, I'll turn it over to John.
Thanks, Mark. Hi, everyone. I am John Adams. I am going to talk us through some of the technical challenges that we run through with these workflows. I'm going to zoom into one specific workflow here just to kind of highlight some of the points. There's some recurring themes, actually, that I've heard over and over, and I kind of want to highlight what we look at, what we run into every day, and some of the challenges that we've solved. So really, I'm going to glaze over the details of this slide, but what I want to point out is all of the steps, all of this data that is generated. One thing that was mentioned this morning was gaps, right? It's really hard to connect the gaps between some of these things. And we exist kind of within, another thing that's mentioned is design, execute, analyze. We exist kind of within the analyze space, right? But within even this one workflow, these couple steps within this workflow, there is that same loop, that design, execute, analyze loop. So we found a need for a new product. We call it Sample Management Services. And this is really kind of our metadata management tool. It is intended to take all of these different sources of data, aggregate them, augment them, support our analyses, all these different inputs, and then deliver them in a hopefully generic way, in any way that is desired, to many consumers, whether that's a user, as Mark mentioned, with our desktop tools, all the way up to an automated scheduling system, robotic systems, anything like that. So I'm going to talk us through kind of some of the ways that we approached that, some of the mechanisms that we use. First off, think of it from kind of a very practical workflow standpoint. We exist in this analyze space, and samples are submitted into the lab. So we kind of follow that terminology. We have an electronic submission. And this is just one of the many APIs that we provide. This is the entry point API into our ecosystem. And this gives you a way to feed in the metadata that is known at this time. Maybe it's experiment metadata. Maybe it's more practical metadata about the lab. Maybe it's very practical metadata that Department X is submitting to Lab Y, right? That you can have very practical data captured within it, and we're giving the users the ability to interact with that. We're giving these consuming systems the ability to interact with that. We also have this other set of APIs that can help augment, edit, retrieve is a huge one. We give all these different views into the data that's been aggregated. One thing that we use all is this aggregated augmented data for sample list generation. So every instrument is going to take some sort of sample list, instruction list sequence. And what we can do is we use our APIs, again, either a user standing in a machine, master scheduler, LEM systems, anything can feed into this sample list generation, right? You have data that might be experiment metadata that you want to feed through that sample acquisition. Maybe you have more practical runtime data, and you certainly have practical instrument specific data. And all of that is aggregated through our tools here. And I'll get kind of into the nuts and bolts more of how that works, kind of how that workflow looks, but it's augmenting it all into our series of APIs that are both, again, desktop tool, automated process. We support it both. So I want to talk through some more short-term challenges to solve. Go back to the gaps, right? It's hard to connect the dots. One thing that we also saw very often was kind of a desire for observability into the workflow, observability of what's happening. Great, we've augmented all this data together. Can the user use that in a manual context? Can they visualize what this data looks like? Can they visualize what the outputs look like? One way that we do this, and our terminology didn't quite match up with the themes. I didn't know ahead of time, but look at that. There's a design, execute, analyze. Again, it happens at the macro, it happens at the micro, right? We are within that analyze, but this is what we're doing. We're planning, we have dashboards to allow users, again, to visualize the state of what, maybe outstanding work, right? The state of the experiments that are happening, the state of these acquisitions. You can execute, you can generate these sample lists, and you can report, you can analyze. We have all of these visualizations of the current state. Again, I want to kind of zoom in. This is just one example of our augmentation sample list creation, right? That's a very easy example. It's experiment metadata that comes in through our submission. This is our desktop tool called Sample List Builder. And this is where the user can enter runtime information, either practical information, where did I put it on the instrument, or instrument specific information. So we are actually instrument aware. We communicate with some of our other products, our instrument agents, so that these tools become context aware, so that the user only needs to provide what's needed, exactly what's needed, and very quickly generate all of these different run lists. So we kind of have a few steps here. Again, the different sources of information. And what I want to point out is this is a templatized system as well. So we can support instruction lists, sample lists for a huge variety of instruments. We take sample metadata in a generic way, experiment metadata. We can define the different information that the user needs to provide. We can define the different information that the instrument expects. We can format that in a generic way to the specific instruments that will be running that, whether that's mass specs, liquid handlers, robotic systems, other things like this. We can generate these instruction lists on the fly. Next, I'm going to move into informing. Again, we're kind of within this analyze step, but you get oversight. You can see we have dashboards. We're taking all of the sample metadata and we're making it real time. What's happening right now? What is in an instrument? What is the status of what was submitted? Are we done? Did we run that? You can tell down to a sample list level. You can tell down to a sample level. Maybe you want to go fetch some metadata about that sample. You can zoom all the way in. You can zoom all the way out to see workflow status or even sample data. And finally, I'm going to move into kind of more of our reporting. This is our analysis. How do we close the loop? We take all of this data that we have augmented, aggregated, and finally analyzed, and we provide APIs to report that out. One very useful way that we found to do that is that, we've talked about these workflows being kind of disparate steps, right? How do we connect those? How do we close those gaps? We have an aggregated report that has tracked the lineage of these submissions. So in a purification workflow, you can imagine these very well-defined steps, very well-defined results out of these, but we can aggregate these into a result, kind of a story, right? You can follow the lineage, you can follow the provenance of samples, all of the metadata that is associated with it, we have tied it together and we give you mechanisms to pull that out. It's a very open system. It's very helpful to augment all this data and then you can't pull it out, not very worthwhile. So we give the huge amount of APIs available to pull out either these large aggregate reports. You can zoom all the way in and maybe pull out a chromatogram, pull out exactly what you need. I'm going to segue a little bit into this kind of a nuts and bolts slide, but the real-time nature of this, as all of this is occurring, our sample management services is monitoring all of this. It is responsive. And so we have notification subsystems built in at the core of all of this. It is scheduled notifications. It is scheduled tasks. So as workflow activities happen, a submission is received, we can email a user, hey, it's time to go to the instrument. Somebody sent you a plate of samples that they need to run, or hey, that plate is done. You need to go open our analytical software and review. So all of these things can empower users to be more informed about the workflow, as well as automated systems. We can respond in real time as things happen, as the instrument completes, as the analysis completes. We can provide more feedback and more holistic feedback to other integrators as well, so that these systems can respond in real time. They have more insight into the system as well. Again, we're closing those gaps so that any consumer can take advantage of that. They can have all of that data in one spot. And at this point, you can imagine this is kind of our output. And so I'm going to hand it over to Taylor to talk more about how Allotrope helped us in this area.
Hey everybody, Taylor Janoe, developer at Virscidian. I primarily worked on developing the output process that we do from our product to be able to actually output the Allotrope simple model in a usable format. And really, we were looking to solve a specific need, right? We have our own internal mechanism on how we store data, how we read data, all those good things. Everyone here does. We've talked 100 times about the data silos, and we had a need to be able to create some sort of standard output that could be used by certain customers, vendors, et cetera. And that's where Allotrope came in, and that's kind of the space we jumped into. we needed to have the right mechanism in order to do this efficiently. So as somewhat in an automated fashion, and we had a good way to do that through our SMS platform. And we faced various challenges along the way, as I'll cover towards the end here. So through our software, like John had mentioned, we basically have a publisher subscriber model, which we're able to use to push out notifications to subscribers, whether that's HTTP client, an email address, a file drop. We can send those out. And really the mechanism here is that SMS backend is pushing it to them. The value in Allotrope is it's a standardized format, right? So it's not just Virscidian's data model that they're receiving in our aggregated report, which has these, results, right? Because everyone here is providing a value through their hardware, their software, that sort of thing. So how do we actually inject our value into a standard model? And that's kind of the challenge that we faced, and kind of an open-ended question is that's really a mechanism that we all need to figure out on how to do appropriately without distorting and twisting these schemas and models into making it Virscidian's allotrope output, right? Like it's got to be a standard common format. So we worked with various members of the Allotrope team just to kind of make our vernacular and semantics sync up, because we have our own words for different things. Everyone here does. So that was kind of one of the challenges. But along the way, it kind of helps open up some ideas and some thoughts and some features that we've got some ideas about. So we've covered this in depth about what the ASM is. Like I said, we can drop a JSON file, we can send HTTP post call, all those good things. And some of the things that we're looking to be able to do with Allotrope is we have all these robust results, like in purification, in the preparatory stage, you have the fractionation of a sample. Okay, well, how do I put in that fraction detail? How do I put in my specific analysis on, hey, we think this fraction's the best? Ben talked about yesterday and adding the gradients. And we've been working on a new project where we're actually doing calibrated gradients. Where can we put this information into? We're pretty open. Our output, we have a concept of how we output our metadata, and we push that out, and it's openly available to whether it's a automation vendor, client, user, desktop who just wants to look at results, or machine learning center, various ways. We've got no problem sharing our information. It's just, okay, well, how do we put it out in the right format? And I think Allotrope has a real spot to be able to solve that problem for not just us, but for everyone here. Here's a little demo, basically. So what we're walking through, right, it's just a video of my desktop, super exciting. But it's a raw data file. It's a MassLinks raw data file. I'm dropping it into a folder. I'm basically demoing from our instrument agent acquisition through our full analysis to our full output, an HTTP client post, and a file drop mechanism. And I am not sure how to get this to play. Cool. All right, so we have the file drop there. It's being picked up. We're analyzing it with our own internal processing methods. I'm checking our dashboard, our user UI. I can see that the sample is ready, and if the sample is ready there, then I know that our data has been produced, and our subscriber, which is a file drop location, now has an ASM readily available with all our analysis on it. So we've seen the execute side and the analysis side in a matter of a few seconds with a single sample. So it's one of the ways as a provider, right, that we want to show, hey, this is how we're actually implementing this with customers. And is this something that is useful? Is this something that needs tweaking? How do we make this better? And I remember yesterday, eventually you guys were talking about your custom converters and that sort of thing. And there's a huge need to be able to have collaboration and that sort of thing. And it's, where do we put these things in place? Because right now for us, well, we don't have a huge need to be able to ingest an ASM necessarily and read that information because we've got instrument readers that can use the SDKs from name your instrument vendor and analyze those results. But hey, yeah, there's a need, say the instrument vendor has produced an ASM. We've done our analysis. We want to update it. So whether that's like the Zontal platform and we're storing these multiple different versionings of our ASM or even a direct input. So that's why I really see the collaboration coming into play is, right, we want to all put input. We want to all input our value into this standardized format. How do we make it so we can do that? Because a single customer, they're not going to go to just one vendor typically in my whole lengthy 2 years of experience. They are not going to go to one specific vendor for every single solution along the way. It's usually a consortium of different vendors because everyone does things a little differently, meeting different needs for the workflow. And at the end of the day, interoperability is a big factor, and us being able to have that common language, those common mechanisms to be able to do that is going to play a big piece in that. The challenges we face with this, obviously, like I said, newish to the space personally, but we are new to the allotrope field as well. So coming to terms, semantics, that's always a challenge. So how do we match up our internal model to an ASM output? We're having a conversation with someone at lunch actually, and that's a method means different things to different people even. So, okay, we've got it defined in a schema as a method, but that doesn't mean the same thing to any one person. Internally, we have our own processing method that we use, but then you may have an MS method, et cetera, right? So those are some of the challenges that we face on initializing this feature. Yeah, I think that covered both of those in one fell swoop, actually. And then I from these conversations that we've had over the last 2 days, I think part of the challenge we face is the integration piece, right? So how do I push my information to the LIMS, to an EON? How do I get information from an instrument itself? Like if there's a need, we are going to change our ways. That's just the way business is driven, right? The need is going to force the features and the future development to take place. So being able to work collaboratively to develop those features and that commonality is going to be a big piece for us. So yeah, that's all I got as far as the presentation goes. Thank you all for your time.